So here, instead of a pool of mortgages, right, what we have is a pool of mortgage backed securities, which obviously will have a pool of mortgages behind them, right? Each of those separately. So what you do is you have a collateral manager, and that collateral manager is going to manage this pool of mortgage backed securities, and then what they can offer to the investors is different tranches which can be customized in different ways depending on what the investors want, and this entire process is called structuring. So I mean, so far you've talked about credit tranching and time tranching. We've talked about credit tranching and time tranching, but now we're going to talk about even more types of structuring where we might want to just split and strip the payments into interest versus principal, right? That one just pays the interest coming from this pool, one just pays the principal. Investors can have different types of requirements, or you can have a structuring where we actually have sequential pay tranches where interest is paid to all, but first the principal is paid back of A, then B, then C, then E, C, then D, then E. So because the principal is coming back to A first, so they have the highest prepayment risk or the highest contraction risk, whereas E has the lowest contraction risk but the highest expansion risk, because they will get paid the principal last. So if somebody really doesn't want expansion risk, they can go for A. If somebody doesn't want contraction risk, they can go for E. So this is the type of structuring that we're going to see now here. The major difference between a CMO versus your normal pass-through is that a CMO is not just consisting of mortgages, but it is a pool of mortgage pass-through securities, right? So it's like a two-layer thing, that first you have these mortgage pass-through securities which are based on pools of mortgages, and then using those mortgage pass-through securities you make another pool which the collateral manager manages, and that is called collateralized mortgage obligations. Now, what are the advantages of doing this? Well, you can really play around with it and try to create customized cash flows which meet the need of certain investors, right? So if a pension fund wants 5% for the next 30 years, you can try and make that work. You can create a tranche for them which will give them 5% for 30 years, right? How would you do it? You would take this pool, right? And then you would say, okay, this is the packed tranche, the planned amortization, and this is your support tranche. So if there is any prepayment, the support tranche takes that. If there's any contraction, the support tranche takes that, which is the prepayment. Or if there is a delay in the payments, if there is any expansion, again the support tranche takes it, right? But you try to maintain the weighted average life as per the weighted average maturity for this packed tranche. And also with respect to the coupon also you can do it. So let's say if the weighted average coupon is changing, and if there is any problem, then what we can do is we can even split this in terms of a junior or an equity tranche that takes the hit, or we can have a floating rate tranche over here, right, that takes the hit of any change in coupon, and we fix this tranche for these guys. So all kinds of customized arrangements can be done depending on what the investor wants. Now we're going to look at sequential pay. Now what's happening in sequential pay is that everybody is going to get their interest based on their outstanding principal, interest paid to all, and that's based on your outstanding amount, right? Usually even the coupon rate is different. We've just kept it the same in this example just for the purpose of simplicity. Usually it is different, but the key concept that you need to pick up is that the principal is paid sequentially. So first, principal paid sequentially. So first A will be paid off, then B, then C, then D. So D has highest expansion risk. They have highest expansion risk, right? And your A has highest contraction risk. Yep. Right? So this is basically sequential pay CMO. And interest, of course, is paid to all based on whatever percentage of coupon you have agreed to pay them multiplied with the outstanding amount. But the principal payments, they will be given to A, then B, then C, and then finally to D. So what happens because of that? A has the highest contraction risk while D has the highest expansion or extension risk. And A and B protect C and D from contraction, and C and D protect A and B from extension. You can also strip those cash flows coming in from the pool into different layers where some can be principal only, some can be interest only. You can even have Z tranches that don't pay anything until don't pay any interest until the principal starts coming in, and then all the accumulated interest, the accrued interest is paid out as well. So even that type of situation can be there. This is very interesting, floating rate tranche. So let's say the weighted average coupon of the pool is 5%, right? What they can do is they can offer a floater and an inverse floater, right? A floater and an inverse floater. And if interest rates go up, so the rate that we will offer in the floater will go high. So let's say we're offering 5% to both initially, right? Now if interest rates go up, we'll offer 6% to the floater and we'll offer 4% to the inverse floater, which is inversely related to the reference rate. So let's say the reference rate is initially 5, but it goes down. If it goes down, we will offer 4% to the floater, and because this one is inverse floater, it will go up as the interest rate goes down, and we will offer 6% to them. But either way, we will not be in a loss because we're going to take that 5%, and in one case we're going to pay one of these more and the other one less, or we'll pay one of these less and the other one more. But either way, we are going to be safe because we've based it on our weighted average coupon, right? So this type of structuring can be there as well. One of them will offset the other. And of course, this is something I've been talking about for a while now, that this is your pure time tranching where you have your pack tranche and your support tranche. Support tranche bears both contraction and expansion, and your pack tranche is the one which is the